let me introduce our speakers for today. I guess we have a very interesting subject. The UK Space Agency are here to talk to us. So Henny and Joshua, can you just introduce yourselves and tell us a little bit about yourself, please?
Yeah, hi everyone. My name's Henny Abrasaid. I'm Telecoms Policy Lead for the UK Space Agency.
I'm Josh Brayford. I'm a Space Project Officer, which it's about as cool as it sounds.
So we're here today to talk about 5G, and I'll be, a lot of people haven't heard of the UK Space Agency before, so I'll be running through a quick introduction of who we are, what we do in Scotland, and then we'll be looking at 5G and what it means for your sector.
Super. Thanks so much, guys. Now, our other host for today is our very own Luca Carrari, who runs the Innovation Network function here in OGTC. So, Luca, you invited Henny and Joshua here. Why did you think it would be a good idea?
Well, we are in the middle of technology revolution. Some call it Internet of Things or Industry 4.0. The point is that there will be a lot more and more devices connected. One of the estimates is about 200 billion devices connected by 2020. That is just a few months away. So the connected devices require connection. And when it comes to Scotland and offshore, connection is a bit of a challenge because the cities are one thing, rural Scotland is a different thing, and offshore is a different thing again. So satellite 5G might be an answer. Satellite 5G might be part of the answer, might be the solution. I think that's very exciting. When you look at the future of the industry, more automated, more remotely operated, again, more communication needed. Where is that bandwidth coming from? And that's why I think that hopefully today we get some answers and some inspiration for what the future is for the connection of rural and remote areas through satellite technology.
Thanks, Luca. With no further ado, over to you.
So, just like to say thank you to Luca for inviting us here to speak. So, a lot of people haven't heard of the UK Space Agency. So I'm just going to run through quickly who we are, what we do. So our sort of formal thing is that we're at the heart of the UK efforts to explore and benefit from space. We're responsible for ensuring the UK retains and grows its strategic capability in space-based systems, technologies, sciences, and applications. So I'll explain how Josh and I work on technologies and how we access applications as well. So in terms of what that means, in terms of what we do, the UK Space Agency is responsible for commercial space flights in the UK. And you might have seen recently that we have put, sorry, I've just got to get the numbers, a £50 million programme to kickstart small satellite launch and suborbital flight. And we chose a destination not very far from here in Sutherland to do that. So that's going ahead. And we'll also be seeing other launch sites coming to fruition in the UK too. So we also do our traditional knowledge and innovation, so science and space exploration missions we're still involved in, and you'll see our contribution on those. We continue to collaborate with international partners. So we work very closely with the European Space Agency, which isn't part of the EU, and that collaboration will continue. We are regularly signing memorandums of understandings with countries and their space agencies around the world. And lastly, my directorate is the Growth Directorate. And this is really the reason why we have a space agency now. So I'm just going to read a few numbers. So over the last decade, every year the space sector has grown by 8% a year. It currently has 38,000 people working in it, and is, contrary to a lot of perception, there is a growing national spread. So on the way up here yesterday, Josh and I stopped in Glasgow, and we had the pleasure of visiting Clyde Space, who are a world-leading manufacturer of cube satellites. They build those in the centre of Glasgow in an office block, and they go up in space and are used and bought by people around the world. So we use those examples to show that actually space is a lot more accessible than ever before, and that's really why the agency's here. So all of technological leaps in telecommunications, in Earth observation, have meant that actually the UK, for the first time, has a stake in the space global market. And the aim of the UK Space Agency is to grow that market in the UK and to take a share of it. So quickly, I'll run very quickly. So my directorate is the Growth Directorate. We look at regional growth, so we have colleagues who work around the country. I'm sure you'll start seeing more UK Space Agency people in Scotland now that there's the Sutherland launch site. We particularly work on telecoms technology, and we do telecoms policy work as well. So I know from visiting the Quantum Showcase in London last week that we share a common interest in quantum technology with the oil and gas sector. And that's, for us, a key enabler for future commercial space applications. We also work a lot on 5G, which is why I'm here, and which I will come to in just a minute. And we do all of that through a European Space Agency program called ARTES, which is Advanced Research in Telecommunications Systems. And very much like the OGTC, we co-fund industry. We're led by industry. What industry wants us to co-fund, what direction they want us to travel in. We co-fund industry to develop upstream technological developments, and that could include £100 million space segment programs. It could include small terminal manufacture. So the terminals industry in the UK is enormous. And it's basically, you can make a terminal that can talk to space relatively cheaply, and that means that there's a lot of entry-level companies operating in that space. And lastly, we operate in the downstream segment as well. So we have a business applications team, and they co-fund applications using space data, using space systems. So we have programs that monitor the seafloor and use that data for different things. So, sorry, I've overrun slightly. So we're here to talk about 5G today. So the big question everyone has is, what is 5G? And the public perception, and the one that's sort of pushed out a lot by the mobile operators who are going to be selling 5G, is it's faster connection speeds. Some people might know that it's lower latency, but really it's sold as, your existing browsing habits, all of that just gets quicker. And for most end consumers, that will continue. But actually 5G is so much more. So 5G is so we had 3G, 4G, it was a continuation, it was getting better, an incremental change. 5G is a complete split from what happened before. So at the moment, people talk about megabytes per second connectivity. People are going to be talking about gigabytes per second connectivity. That's in satcoms, that's in terrestrial, that's in mobile. And it's to the point where ultimately you won't talk about your connection speed because it will be irrelevant. You'll never need to use your connection speed. So that is quite a promise, but bear with me. So this has been enabled by opening up new parts of the frequency spectrum. So it's not just and that's really what's behind the leap. So it's not an incremental change where people are making better use of the existing spectrum. There's new spectrum, offers new opportunities, and equally the technology behind 5G has really leapt to the challenge as well. So we will see initially 5G being rolled out on mobile, and that's because of modems for mobile technology being built in high enough volumes to be able to do it cheaply. And so that will be the first stage. So in terms of space, though, a lot of people may have had contact with satellite technology before, and it's often thought of as sort of a last resort. It can never really compete with terrestrial systems. Certainly, probably couldn't compete with mobile systems up until a few years ago. But actually, in our program, we have the pleasure, really, of existing 5 years into the future. So we know what industry is working on now, and we know what's coming. And what that means for space is that the last generation of what we call high-throughput satellites are changing to the suitably named very high-throughput satellites. And they will have connection speeds of gigabytes per second. And the problem with satellite, obviously, you broadcast to a very wide area, and all of your users take a little bit of that. And so eventually, there's not much to go around. But satellite technology has gone through a transformational change. Like I set out earlier, really it's behind the reason there is a space agency, why I'm here and Josh is here, and why we're able to have the launch facilities in Sutherland as well. And that is because every single aspect of satellite technology has undergone fairly revolutionary means. So we have very high throughput satellites, we have ground terminals that can track satellites using electronic phased arrays, which for a long time was sort of a mythical dream that would one day be achieved. And actually we see them now, and we'll see them being rolled out soon. And so what that means is that satellites can keep up. And you can get the data throughput that actually satellite can form a very important part of 5G. So, turning to 5G, so the challenge of providing 5G for operators, be they mobile, network, or terrestrial, or satellite operators, is mainly connectivity, but it's also the operating system. So that means, well, let me explain. So 5G isn't just high data throughput. It's seamless, ubiquitous high data throughput. So you are always connected, and you always have access to your data. And that doesn't just mean you. That means your devices. That means everything you do at work, everything you do at home is connected all of the time, wherever you are. So every inch of the UK actually needs to be covered. So farmers, their fields, their cows, their cow sheds, your oil rigs, everything in between. You know, on the train up here, it was really insightful. We had areas where there was literally no connection, and then areas where it was a better connection than I have in London. And it was all dark outside, so I couldn't see what was going on. But it was, it was just this sort of sense of in and out of connection. And actually, for 5G, the important thing isn't just you, it's your devices. And this is where satellite comes in. So, sorry, I'm just aware of time. So what we need to think about with 5G and satellite connection is that it will connect your Internet of Things, it will connect massive machine-to-machine connections, it will enable AI in the cloud, and it will enable mass automation as well. So that's autonomous cars, that's autonomous drones and other vehicles and other connections to vehicles, including connections to trains. Connections to ships have been around for decades, and we're seeing those being transformed as well. So I'm just breezing through because I'm aware of time. So for 5G, satellite and 5G, what we're not saying is that you can just connect to the satellite and you'll get 5G. 5G will be a series of overlapping networks to provide that seamless connection. So satellites can provide some of that connection, but your existing infrastructure, so your fiber, your mobile and cellular structure, all of these things are going to work together to build 5G. And that is the step change. And that's a step change for the satellite operators as well. So previously, you would have mobile operator, a network operator, and you'd have different contracts. And very few people, maybe in this room a few more people, would actually ever have a satellite phone and a satellite contract. And actually what 5G offers is the chance, and what a lot of satellite operators now realize, is that they need to operate converged networks. So ultimately, soon we hope, customers will be able to use all of those networks, fixed wireless provided by fiber, or cellular provided by masts, or backhaul provided by satellite, and they won't know or care which ones they're doing. And their billing system may tell them, but it'll be an afterthought. It's not the defining thing anymore. So really, satellite 5G isn't about replacing existing infrastructure. It's about providing a seamless service by wrapping up all of the existing infrastructure and being able to make the case to consumers that there is seamless, ubiquitous connectivity. So, obviously, we're here to talk about oil and gas, and satellite, in this sense, plays to its strengths. So it's still resilient, like it's always been. It's still able to do things like backhaul that it's always been, but at a vastly different scale. And so in rural areas, one of the really exciting things with all of this is that you are having fiber put into rural areas because the business case now for connectivity is there. So you're having, you've got fiber in the North Sea, you've got fiber going to Orkney, and this is amazing stuff. The business case is there to actually spend the money connecting remote and rural areas. And so actually, in some ways, for SATCOMs, the gap is getting smaller. And you kind of think, well, is that a good thing? But what we know is the gap is getting smaller, but it's more important than ever to fill. And equally, SATCOMs and the technological changes that are behind SATCOMs mean that not only is it cheaper to fill, but you can fill it with more certainty. And the direction of travel from the operators is that you can fill it in a converged networks format, so that for a customer, the important thing for them is connectivity. So I will move swiftly on and show you a short video from the European Space Agency, who we work with on 5G.
Being connected is everything. Both visibly and invisibly, connectivity keeps us learning, moving, communicating, and safe. A revolution in connectivity is coming as the new generation of wireless communication, 5G, moves us closer to being connected to everything, everywhere, at all times. 5G enables the seamless interworking of different technologies and networks at speeds and performance that no previous generation has been able to touch. With 5G, your mobile phone, home, car, and even your city can all be connected, sharing information and responding to commands instantly, regardless of when or where the command is made or how much data it requires. 5G means downloading a film in seconds while on the go. It means a world where the logistics of industry manage themselves. It means being connected everywhere, all the time, immediately and securely. But no system is perfect. To support these applications, 5G will need uninterrupted coverage at unprecedented capacity, which terrestrial networks alone can't guarantee. The connection can be blocked by buildings, weaken in low coverage areas, or not exist at all. Luckily, this terrestrial problem has an out-of-this-world solution. Satellites can provide the channels, reach, and ubiquitous connectivity that make 5G possible. The European Space Agency is working with its partners to develop integrated satellite and terrestrial-based 5G services. Space technology can help fill the gaps in ground-based networks, extend reach, improve data protection and reliability, supply the massively increased volume of information required for all the applications that 5G enables, and make 5G part of your everyday. With the help of space, the future of connectivity is closer than you think. To join ESA's Satellite for 5G initiative, visit our website.
Thank you very much. Now, I was going to give you a few use cases, and I don't want to get ambushed for running over as I've told I will be. So I might just give you one and focus on it and quite well. So as you saw at the end there was a hospital, and there was talk of big data transfers. One of the use cases that the satellite applications catapult are working on is ambulances that are connected either by a terrestrial network or a satellite network, where your paramedics, instead of having to write down your blood pressure, your pulse, your stats on their hand on a notepad, get to the AR and reel it off to a doctor who then has to process it and look at the situation. It's all going to be done via a connected sort of iPad that the first responder will have. You can input the data. It will then live track your patient with your heart rate monitors, with your blood pressure, and your doctor, when they get to the hospital, is going to have everything in front of him. So he's not going to have to worry about these transition periods. You know, it could be a really high stress scenario. Somebody could be, minutes away from dying. The doctor's going to know exactly what he's facing when it gets there. And that means that, it takes a lot of data. It's going to have to transfer. And if you're in somewhere that's really rural, really remote, where there's no connectivity via terrestrial, the satellites are going to give you that converged network. It's there as a support. It offers reliance and reliability that, it's not guaranteed at the moment. But it also then links into a connected vehicle through an ambulance. How often when you hear an ambulance sirens, you have to look in your mirror, you have to look where the ambulance is coming from. You then have to move out of the way. If you're at a traffic light, there can be a bottleneck, and ambulances can take ages to get through. Sometimes it is life and death. Sometimes it's not, but sometimes it is. If your ambulance is connected via an IoT device, which is then connected to other connected cars and traffic lights, it can give a pre-advanced warning to the cars in front before you hear the sirens to move out of the way. It can talk to the traffic lights to say, there's an ambulance coming, we need a green light. The green light can come on as the ambulance gets there. It means that roads open up, there's no bottlenecks, and an ambulance can go straight through. It's small things like that that are actually going to be great use cases for 5G. And people don't really realize that all of this requires a lot of data, and it requires ubiquitous coverage. Hopefully this is where satellite can step in with terrestrial networks, with mobile networks, and just be that converged network that we all just use every day, and we won't know about it. And with a second left, I'll take it.
Well done. Thank you very much, Joshua.
Yeah, I do have a couple more use cases, but you can ask me afterwards.
Well, that was a heroic effort to fit in your segment at the end there. Thank you both to Henny and Joshua. So we have 20 minutes for questions. Does anyone want to kick off with a question? At the back, Sarah.
Hi, Sarah DeBoer, Project Manager for the Wells team at the Oil and Gas Technology Centre. When it comes to the satellite connectivity, is there anything that affects the ability to connect with the satellites? So is there anything that's likely to knock out signals or make that unreliable?
Yeah. So for this audience, it's quite interesting. So we tend to split areas into three. So we've got urban, rural, and remote. And in an urban area, satellite isn't very good. Can't go through buildings. It doesn't have the same. It doesn't really go very deep into buildings at all. In a remote area, it's absolutely fine. In a remote area, there's even less buildings, even less trees. So yeah, that's how it's split.
You might have heard that old geostationary satellites used to, if it was raining quite badly, you'd lose your Sky TV because it used to be affected by rain fade. But as we're bringing satellites down and closer to Earth, it's not affected by those things anymore. So the kind of rain fades and bad weather, those issues are removed. So there's a stronger signal, and it's a lot more reliable than it ever used to be. As we said, it used to be a last ditch, whereas now it's becoming a lot more plausible.
Thanks.
Thank you.
What are 5G's capabilities in terms of like subterraneous connectivity, and how far down without it being sort of interrupted?
So satellite can't go through water. So obviously for this audience, I know you're interested in undersea communication too. But there are proposals for buoys that can talk to satellites and access fixed network masts, and there's often very little problem once you're out of the water. Really, you can have a buoy or some kind of terminal on a fixed position.
Sorry, my question was just about terminals. You mentioned terminals earlier on. I just want to explain what is a terminal. I mean, how does that help with the big picture, if you like?
Yeah, so a terminal is a device that basically speaks to the satellite and then will transmit your data. So you can see it as a Wi-Fi router is effectively a terminal that gives you your Wi-Fi. A satellite terminal is very same. It used to be big, clunky, and expensive, and very hard to work. Whereas now they're made very user-friendly. It's kind of, you plug it in and you work it just like you would a Wi-Fi router. You get a simple 3-step instructions, and your satellite terminal would work the same as a Wi-Fi terminal. And if we are having a converged network, then they would both use the same. They would both use Wi-Fi and satellite interchangeably.
And just to add, like your phone is a terminal, obviously,
yeah.
and terminals now come in many categories, but previously people think of like the satellite brick phone, and that was a terminal. That's not what we're talking about here at all. So a lot of converged networks your phone will be able to access the terminal, and the terminal will broadcast and then backhaul. So the technology for the consumer is becoming more and more streamlined.
So I want to address the elephant in the room. I used to work for Motorola, and we launched a whole constellation of satellites because we thought that satellite phones were going to be the future. Unfortunately, we did have not quite bricks, but the cost of making a satellite telephone call was exorbitant and wiped out the whole program. Now, when we're talking about the oil and gas industry, we're talking about transferring vast amounts of data to get it to shore. Can you give me a guarantee that that's not going to cost an arm and a leg?
So I can't give you a guarantee.
No, I don't.
But what we're seeing with the high throughput satellites and the very high throughput satellites is that the price point for data is falling through the floor, and that's because people are using so much more of it. Our colleagues in the business applications team, they use Earth observation data, and more people want more close to real-time Earth observation data. And that is enormous amounts of data to be able to access. So there's a demand that's driving down the price of that. And partly that's because of the components on the satellite are getting easier to build. So Clyde Space in Glasgow down the road, it's not really down the road, is it? They produce all kinds of satellites. They're CubeSats. They look like a very large box of cereals. They're that size, and they spin over. They don't follow the position. They spin across in constellations, and it's that kind of technology that wasn't available then. So I know the time that you're talking about, and actually we're in a similar position now where we've got companies like OneWeb who are proposing constellations, and at the same time you've got fibre being, the case for fibre pushing. And actually what you've got now is this much more nuanced business case of the converged network. So where before it was either or, this is your phone through your satellite, or you can use a mobile and it's much nicer. Now satellite companies realise that they need to work together, and that the fibre connections is what is driving their business. Those fibre connections are using huge amounts of data and getting people used to using huge amounts of data. So it's actually a very symbiotic relationship. And it's that difference that I think now provides much more of a nuanced approach to how these constellations will operate. So we work with OneWeb, who are based in London, and they call themselves a telecoms provider. They build satellites, send them up, but actually they're a telecoms provider.
Yeah, with this coverage, extended coverage, are we going to get an increase in the GPS as well? Will we see that change?
GPS is different. So it's a separate system that provides your position according to a particular satellite constellation. What we're talking about now are satellites that are purely telecoms. So you'll have your data. You'll have data throughput.
So there's no way that the convergence or the spectrum change will be able to improve that at all?
Well, the GPS is an old American system anyway, and the European ESA are developing the Galileo system, which is kind of Europeans' answer to GPS. So the idea with that is it's going to be more accurate. It's going to be a better system than what GPS currently is, because it's an old American military system, I believe, and it's quite old.
Good afternoon. Thanks for the presentation. Steve Sherman from M&P. I'm curious, we're talking about constellations. So my question would be, are these low Earth orbit constellations? I'm interested to know kind of how the kind of number of constellations that are being proposed by different commercial ventures? So is it a large number, a small number? And the number of satellites that go up in a typical constellation to deliver this technology, and the kind of rough weight. We're talking about CubeSats. Is it a large constellation of CubeSats, in which case there's not a lot of weight, but that's going to be relative to how many CubeSats you need to put up there and how far up there you need to go with them. So
yeah.
Sorry,
So
it's a few questions.
No, it's fine. So we can digest it. So I'll start with the constellations. It's very much a race to market. So kind of the first people that get up there, they're going to have the market share because they've got the first constellations up there. There's already Iridium in America, have a constellation of about 70 satellites currently. They've been launched. You'll see it on SpaceX. They've been launching them.
Is that built on the original? Sorry, normally I have a problem projecting. Is that building on the original Iridium kind of fiasco from
So,
the 70s?
so Iridium has gone through a whole iteration, and the 72 up there are the functioning commercial element.
Okay.
Yeah. So yes. Yes.
But I believe they plan to add more. OneWeb plan to have between 800 to 1,100 to give worldwide coverage. SpaceX have said they're going to do 4,000 in LEO and 9,000 in MEO. I don't think that's going to be achievable, but we'll see. Elon Musk always surprises. But that's, you kind of need about 800 to 850. This is what OneWeb suggests to cover the whole world, to give connectivity everywhere. They're going to be in low Earth orbit, as you mentioned. The weight of them as a CubeSat can weigh anywhere from 1 kilogram to 50. I'm not sure the exact weight of OneWeb's.
They're more sort of washing machine size.
Yeah.
So they're not cube, they're small.
Yeah. But,
I think low, yeah, I don't know.
Maybe 50 to 100, yeah. Yeah, well, yeah, so they're probably going to launch 10 at a time every few months.
Yeah.
Every 3 months they're going to be launching 10 at a time into 18 different planes, so around the Earth.
Is Sutherland capable to that point, Sutherland, that it can deliver?
Yeah. That's the idea, is it'll be able to launch small satellites, maybe not to the weight of OneWeb, so I'm not too sure.
Yeah, I don't know about that particular company, but
Clyde Spaces, for example, will be able to launch from Sutherland, and they'll be able to put.
Where the cadence isn't going to be a problem.
Yeah, so yeah, we don't need to get into geostationary orbit. We just need to get into any sort of polar orbit. And once you're in the atmosphere, you can use orbiting vehicles to get you where you need to be. And once you're in low Earth orbit, you're going around it loads of many times. You can pop it into the orbit of the plane, and it will just go and do its thing.
We've got about 5 minutes left.
Hi. Yeah, I have a very quick question. When?
Good question.
I don't know if that's the question on everyone else's mind, but I can see a use for it today, and so I want to know when I can use it.
So we know mobile networks are starting to roll it out next year. There are each network operator, I think, has a series of cities that they're trialing it in, and you will start seeing 5G capability in handsets, I think next year is the plan. So as a mobile terminal user, you will probably start to see some aspects of it next year. I think the 2020 Olympics in Korea and Japan are going to be fully 5G functioning. And they're sort of the global leaders, well, one of the global leaders in 5G. So that'll give you an idea that we will come after that.
So that's the land, the terrestrial side, but the satellite side.
So yeah, OneWeb start launching next year. So that in their test launches towards the beginning of next year, hopefully. The launches are always pushed back and delayed for inevitable reasons, but they plan to start launching towards the end of next year to get them up and in place. So the possibilities can be there from 2020.
I think just to add on that there's a big difference between the technological side and the application side. So the technological side will start very soon, but some of these really advanced applications, they're going to take a while to filter through and to see what people want. So these are the things that we think people will want, but obviously you work in a very specific sector, you want specific things, so it's going to be driven by you, really.
Okay, so just maybe following on from not the previous question, the one before. So I know Tesla got approval for, not Tesla, SpaceX, same thing, perhaps. Another 7,000, so a total of 11 or 12,000 satellites. So I guess, is that a mixture of low Earth and Middle Earth orbits?
I believe SpaceX is up.
But I mean, so that implies there's competition and you're talking about first to market, but and you're also talking about converged networks. Do you see these guys working together? Will that have to happen? Or do you see it being segmented out by area and region?
So I think what's interesting about the satellite constellations is that you will have competition. So you'll have wholesalers operating in the same space, and there'll be operators on those wholesale networks which will compete with each other, and they will compete across the wholesalers as well. In addition to that, a lot of the constellations that are being proposed are purely telecoms constellations. A lot of them might be Earth orbit constellations. So it's there's a lot of different things going up into space, and as a sector, I expect that you will use all of them. You know, the new Earth observation constellations that are coming on board, you will want to access that data, and you'll want to access the commercial telecoms as well. So and just to give you an idea about terminals for the constellations, it used to be that you had to, put your satellite on the side of your house according to whether it was north or south facing, and now a terminal, you can get a terminal sort of that big, and it's electronically steered. And what that means is that as the constellations race above you, you'll have one or two satellites ahead, and rather than sort of chase it yourself, these are very, very small sensor arrays, and they will move. You won't see them move, and they'll know when the next satellite is coming, and so your phone call using the constellation will be uninterrupted as it transits through different satellites in that constellation.
Afternoon, Roger Essen. I look after decommissioning at OGTC. There was an interesting programme that Sky at Night covered microsatellites during November, so quite interesting if you want to find out a bit more. And it covered the space industry in the UK and the launch site in Sutherland. But my question was, as Stephen was saying, we're forecasting 12,000 of these going up over the next decade, and technology inevitably moves on to the next thing. So the space is getting pretty crowded up there. Are we building anything into these to decommission them and bring them back to Earth?
Yeah, of course, and I think it would be reckless of us not to do that. So now part of licensing agreements, you have to establish how you're going to get your satellites back out of there. If you're aware of space, you already know that there's a lot of space debris. So part of a lot of constellations now, they have work packages involved in their programs that mean they have to demonstrate effectively how they're going to decommission their satellites, whether that's getting them into orbit for it to be collected by something bigger. They've really not established how it's going to be done yet, or whether it's really lowering them down with something like a sail, essentially, to make it burn up and then kind of disappears. Of course, the lifetime is only going to be about 5 years, so when they're up there, they're then developing next generation, so technology is going to keep up with these low Earth observations. It's not like a GEO, which is 15 years lifetime, where technology is hugely leapfrogged. It's going to be 5 years, and then your next generations are going to keep building and working.
Thank you very much, Joshua and Henny. Thank you. Let's give them a big round of applause. Well, that was very interesting. Thank you for coming, gents, and sharing that with us. And I can just